Um, Welcome. My name is Omozo Cosmas. I'm going to explain exploratory data analysis for our priority purpose, English to Uganda. My project is leveraging machine translation in healthcare for African languages, specifically English to Uganda. I think this is obvious. We are trying to import the libraries we are going to use for reprocessing the data. Amongst the Seaborn, the Natural Language Toolkit, Word Cloud, Text Blob, and several other languages like SQL. That's the entire process. Here we read our file corpus and we try to view it. As you can see, it's not quite clean. We have some unnamed columns, which we remove here to try to have just each monolingual corpus, the one for English and then the one for Luganda. Here we try to count the number of words in each sentence for each monolingual corpus. Like you see for Luganda, the first observation has 9 words, and then the one for English, the first observation has 9 words, and then the one for Uganda, it has 6. And we try to more of like get a clear view here, plotting, having more of a distribution of words in each sentence. As you can see for English, roughly, if I'm saying most sentences for English have something like if this is like 5.4, it's something like 5.5 words. And then for Luganda, minimally, most sentences have close to, this is something like 5 sentences. I'm being accurate with, yeah, this seems like 5 sentences. That's what most sentences have, close to 5 sentences. This is good to show you the distribution of words in each sentence in each monolingual corpus. Yeah, this one is just meant to show us the number of observations for each column. For English, we have 200 observations for the English monolingual corpus. For Uganda, we have 200. That's why the counts also correspond. The counts column will also correspond for each monolingual corpus will correspond to the number of observations of that corpus. You see, for count English, we shall have 200, just like English. Count Uganda, yeah. So here we try to do some cleaning to create a column with no stop words. As you can see, for try to remove the theys, he, all those words that won't make punctuations, that won't make meaning during translations. As you can see, when we remove those, we can have words like people being the highest words like government, leaders, Uganda district, like you have removed more of like most of the prepositions that don't carry meaning during translation. Here we are more of like getting the general view. For this plot, we are trying to get the general view of the most appearing words for English. You can literally do the same for Uganda, but so you can see there is the most appearing word with close in the entire corpus with close to 500 counts. Here we try to draw the n-gram bar chart, which is trying to show you the continuous sequence of For example, words that appear frequently in a continuous sequence, as you can see, what is there tends to appear more. They need to be is more like the next, like these words appeared more in a continuous sequence. This is that's the role of the n-gram plot. It's quite good to help you if maybe you want your corpus to comprise of words of a certain pattern, because as you can see in our corpus, we intend to have more medical instructions and prescriptions. So we would want most of these sequences to be about prescriptions and simple medical instructions. So this will be important, highly important when it comes to the phase of adding more domain-specific data to our corpus. To be the n-gram plot will be quite useful. Then the next thing we are trying to do some topic analysis. So topic analysis is quite important, especially when we are targeting. As you can see, most of the topics, the most appearing topics are government, people, Uganda, school. So we would want most of those topics to be about our domain. So this will be highly important when it comes to tailoring the data set to the domain specific topics. And it also always shows you the similarity between topics. As you see, these two topics are overlapping, which means they are quite similar. So 3 and 4, they are very distant, which shows that they are not as similar. They are not so similar, so they are quite unrelated. That's why they are very distant. But these two are quite similar, quite related. That's why there's an element of they are quite overlapping around here. So the goal is usually to have, especially for our field, if we are trying to have quite similar topics, but in the medical perspective, especially when it comes to prescriptions and simple medical instructions. So here we try to output a word cloud. The word cloud is important to show you the word frequency based on using font size and color to show you the most appearing words, the most outstanding words. So we did one for each monolingual corpus. As you can see, people, they, business, government, those words that are quite outstanding. So our goal, this is quite important. You would want these to be more of medical terms, reduce these words from other domains to have more of this corpus was as described in our slides. Most of this corpus was generated from newspaper translations. So, but we are going to add extra domain-specific observations, specifically in medical instructions and prescriptions. So you would want to see those fields, those words stand out more than this. So it will be quite important in informing us about the progress of tailoring the data set to our domain. As you can see also in Uganda, Abantu district, you can see it quite rhymes with what we have in English. The next part is more performing some sort of sentiment analysis, which is quite important in showing you how people, the sentiments in the data set. So as you can see, most of the statements more the high distribution around 0, which shows like they are mostly neutral. But to be quite clear, we try to perform some labeling. Those with less than 0, we're given a tag of negative. Those equal to 0, we're given neutral. Those with the polarity above 0, we're given positive. And as you can see, when we try to get the first 10 observations that are positive, you see we urged to welcome refugees into our camp. They're quite positive statements. And once again, we would want this to be more medical. And then there are some negative ones which we since we are dealing with a sensitive domain, we want to either do away with most of the negatives or reduce them to a very low degree, because the medical field is quite sensitive. You can't be translating and outputting negative stuff. Yeah, that won't be responsible AI. You can't have statements that, for example, that HIV, that output HIV stigma. You have to make sure that this analysis will help us see how far we are when it comes to reducing this negative. We would want this bar to be as low as possible, actually to be zero. That's why sentiment analysis will be highly important. Then part of the exercise is performing some text classification. So we had to add some synthetic topics to our corpus. So we added some randomly from three sort of categories: one, sport, entertainment, and politics. As you can see, this extra column, these are assigned randomly. So when you come to you will see that even if it was random, but the more assignments tended towards the politics, and then quite it's a very small difference, then entertainment and then sports. So it's going to help us to apply a random forest classifier to try to test out hyperparameter tuning. Here we had to add the BERT sentence transformer to get the vector representation of our English corpus, as we are going to perform some classification. So entire essence of this model, the space sentence BERT model, help us to get some vector representations of the English corpus, which will be used in our classifier. After getting our vector representation, we try to split it into the test and the test data, and then the training data, using a ratio of 0.1. Here we use the ratio of 0.1. And then here we try to apply our random forest classifier. Our hyperparameter is the max depth. The random forest classifier is an ensemble learning model, which combines several decision trees to reduce on their overfitting effect to produce a more generalized model. So it's the tree depth, the depth of the tree is highly important. So that's why we initially, when we ran the classifier, we had an accuracy of 0.9, a score of 0.9. So I'll try to tune this. I'll try to do 14 and see. Okay, let's do 15. As you can see, the accuracy increases. You can keep on playing with this hyperparameter until you get an optimal model. But since our pyrocopus has very, very low observations, so just only 200 leaves less data for training the model. So I believe as we increase the training data set, also the model accuracy will also increase. So this has helped quite a lot when it comes to understanding what a hyperparameter is and how you can play around with it during classification. Yeah, that's all I had for you. Thanks for listening.